In this video, we're going to describe the language of linear models, which is called matrix algebra. Later, you will see how this notation is useful to describe models and to perform computation on these models, to code them up, to describe them in papers. But for now, bear with us as we describe what scalars, vectors, and matrices are. Scalars are simply numbers. So for now, we're just going to leave that aside and move on to vectors. In R, write down a series of numbers. For example, as you can see in this slide, you can see how we're looking at the son's heights. You can see that these data are saved in one variable, y, and this is a vector. It's a series of numbers. In mathematical notation, we can do that too. On the right, you can see this bold-faced y. That represents a vector, and it holds in it the n observations, y1 through yn. We can write these vectors for the predictor or covariates as well. So in the example of the dropping object that we showed earlier, this could be time on x1 and then time squared on x2. But it's useful, we're going to see why later, to put these vectors, join them together into what are called matrices. So matrices, you can think of them as a series of vectors, one next to each other. So here we can see a matrix that has n rows and two matrices, and we use the boldface x to denote it. All right, so in R, it's pretty simple to make a matrix. Here we have a slide showing you. We're putting together time and time squared for the dropping object example, and you can see that we can type dim x, and it shows you that it has 25 rows and 2 columns. So we can generally write matrices. They don't have to be 1 or 2 columns. They can have any number of columns. So in general, we write x to represent any matrix with any number of rows and any number of columns. So as you can see here, boldface x represents a matrix with n rows and p columns. And you can see that the indices 1, 1 up to 1, p, etc. represent which entry of the matrix you are. So in summary, what we've done is we've described matrix algebra notation, and we're now getting ready to describe how this is used in linear models. But before we do that, we have to do one more thing, which is learn about a few operations that are performed on matrices: multiplications, the transpose, and inverse.